but we'll go for another 5 or so minutes and stop wherever, whoops, not zoom in, stop wherever the time tells us to stop. Because it's just review, it doesn't mean we need to stop at specific points. The next one, according to our table of contents, and there are textbook numbers if you want to read a little bit more, will be linear functions. So we're going to look at a specific kind of function. The simplest kind of function, if I can find my notes somewhere. Simplest kind of function is what we call a linear function. And remember that function and equation is, for the most part, for us, interchangeable. So linear functions and or equations. Sometimes we do a word problem and it helps us to think of it as a function. Sometimes we are thoroughly fine thinking of it as an equation. It really depends. So it's nice to be able to flip back and forth between these. So let's just have an example where I have y equals 3x plus 2. When the x, the variable, appears on its own, numbers could be around it, but it doesn't have a higher power of x. There's nothing fancy is happening like the square root. It's just an x with some numbers multiplied or added. Then it will be a linear equation, linear function. Let's just see if we take some x values and compare it to some y values. Well, this is an equation, which means I'm looking for x and y numbers that satisfy the equation, meaning when I plug them in, I get the left side equal to the right hand side. So for example, if I try an x equal to 0, then y has to be a 2 to satisfy that equation. If x equals a 1, then y is going to be, that was the question, y is going to be 5. It's easy. And I have many numbers I can plug in. It doesn't have to be anything specific like a whole number. I could say 2.3 if I wanted to be creative. I can plug in any number I want. If I have 2.3 times 3 plus 1, what do I get? Plus 2, sorry. Now it's not very convenient, but I can plug in anything I want, right? So there are infinitely many numbers that I can plug in. As nice as that is to do, it doesn't really help me that much. If I want to just visualize what these sets of points, these pairs of x, y numbers look like, graphically it would be much nicer than a table. So 0 for x and the 2 for y is a nice one. I could say here maybe this is 1 and 2 and 3 and 4. X will be 0 over here. Let's say this is 1, 2, 3, and 4, and I'll add more numbers if I need to. 0, 2 is going to be the point right there. So that is also going to be the Y-intercept, where the point that sits on the y-axis. And how do I get that? I get that by setting x equal to 0 and solving for y. So this is really what I did here. I set x equal to 0. I calculated the right-hand side. I got a y value of 2. Easy. So there's also going to be a point that sits on the x-axis somewhere. I'm guessing over here. But we won't necessarily know in general. That I'm going to get, because that's going to correspond to y equal to 0. So I set y equal to 0 and solve for x. So if I do that, it's a little backwards, but it's the way it's done. I have to solve for x in the equation 0 equals 3x plus 2. And then I would go about my business for how to solve equations, move the 2 to the other side, divide by 3, x is going to be negative 2/3. So it's going to sit, this negative 1, negative 2 is going to sit over here somewhere. It's kind of steep. Let's put it over there. And what's my eraser button? Maybe this one? Sure. Let's make a better arrow. There. Now, if I make a lot of points in my table, I'll see, very conveniently, they all sort of sit on a straight line. And because there are infinitely many of them, they're so densely packed that it looks like a straight line. So we say it's a straight line, but it's not really. It's a collection of points so close together that it looks like a line. And if I could zoom forever, I will see the points, but it's impossible to do. So we relax how we think of this and just say it's a straight line. So the first things are, because we now know it's going to be a straight line, when the x is just surrounded by numbers and nothing else, one way is to just find 2 points and connect them, and they specify a straight line. And the 2 important points are the x and the y-intercepts. But there are other ways to do that. Even though we're still going to focus on just what we really need to know, we are out of time and have to pause the discussion here. I have it 1.3. Let's say, is that big enough? 1.3. Let's just do number 1 in the problem book. So our function is f of x equal to 2x minus 1. You could have very easily have written y equal to x minus 1. It really doesn't matter at all. When we're graphing it, we use a y. When for some reason, maybe a practical reason, we want to emphasize the input-output aspect of the function, we will use the function name. It's the same thing for us. So you have options. One basic option is to find the y-intercept and the x-intercept, which you can't see the screen, of course. That would make a lot of sense. There you go. Intercept, where the graph is going to intersect the x and the y axes. How do I find the y-intercept? For this and really any function. I said x equal to 0. So let's do that. Set x equal to 0, and it's as simple as plugging in 0 for x, and then I get y equal to negative 1. How do I find the y-intercept? Good review. Highlighting what you may or may not remember. If you remember, it feels good. Easy. If you don't remember, then this is the time to go and remember. How do I find the x-intercept? Set y equal to 0. Nothing here is supposed to be new information, but our memories are tricky things, and we do need time to get into the flow of things. So then 0 equals 2x minus 1. I solve for x. 2x equals 1. And then x equals 1/2. So I could use that to set up my graph here. I'm not going to worry too much about the scale right now. So on the y-axis, let's suppose that's maybe negative 1/2, and that's maybe negative 1. It goes through that point. And on the x-axis, let's make it a little wider. Let's say that's 1/2, and that's 1, and so on. It goes through this point. And the 2 points specify the line perfectly. I can draw it somehow. That doesn't look very straight, does it? Like that. And it keeps going forever. That's one way, and it'll always work. Another one that helps us a little bit more on the practical side of these linear functions is to look at the number in front of the x. That has a special meaning. If it's a fraction already, then great. Otherwise, I can make it a fraction by just putting it over 1 if it's not. This gives me information on how to travel from one point to the next on the graph. The 2 is always going to correspond to a number of vertical steps I can take. Let's suppose I take 2 steps. Those can be small steps or big steps. It doesn't really matter. I like to go as close to the x-axis as I can. So I take steps of 1/2, 2 steps up. And then to get back to my line, I have to take the denominator number of steps to the side. So if I take 2 steps up, in this case, I have to take 1 step to the side to get back to the line. And that's going to be from any point to any other point on the line. So the 2 here gives me a ratio, a 2-to-1 ratio for the change in the y direction. I'll write it over here. Change to the change in the x direction. And we'll call this guy, I'm running out of space, the slope of the line or the linear function. Now, as we look at more functions, the slope will be different, and I can use that instead of going to the intercepts first. And if it has a practical meaning attached to it, then the slope is something nice to meaningful to interpret. The y-intercept we said was -1 because we sort of calculated it. There wasn't much to calculate. Because it's always at x equal to 0, this x term is always going to fall away. And I'm always going to be left with the plus or minus number in my function. So if I have it, let me make a new page for a second here. I'm running out of space. I want to squeeze everything in. If I have my function, oops, too much zoom. Like, for example, the y equals 2x minus 1, it's in the form y equals mx plus b, where the m could be some number and the b could be some number. But the nice aspect of this version of linear function, straight line equation, is that both of these numbers that appear have immediate meaning for me and the graph. The number in front of the x is the slope, which tells me how it's angled. And the b number is always going to be the y-intercept. So if, for example, I have something else, I'm just going to make one up, y equals, let's say 2/3 x, maybe a negative, maybe plus 3, that doesn't matter, something like that. I immediately have information about the function and its graph. I don't have to graph the full one, but we can, might as well. I know that the y-intercept is this number. So let me just put it randomly over here. And let's mark these 2 and 1 and 0. And the slope now tells me if I can put this negative with either one. I could see it as -2 with a 3, or I could see it as 2 with a -3. It really doesn't matter to me. It gives me a way to find another point. That if I start from the y-intercept, I like to move towards the x-axis to just make it easier to draw. That's going to have to be in the negative direction, so I'm going to use this version of the slope, having the negative with the 2, and it's telling me if I move 2 steps down, -2, I have to move 3 steps to the positive x direction, and there's another point that it would go through. So if I want to avoid the x-intercept, I can use the slope instead. And if I want to calculate the x-intercept later, I can do so. Often we don't really care too much about the x-intercept. And there's another way to graph the function using the slope and the immediately obvious y-intercept. Any questions on linear straight line functions? Does it sort of look familiar? I don't want to do too many, because if you feel that I don't remember this at all, it is up to you to go and practice and review, because this is very much a review. All right, so let's do maybe a 1.2, number 4. Let's just show that in case you are confused how to get to the problem book. Do I have space? I have space. So I want to look at 1.1, number 4, for example. I have 2 points. I'm looking for the straight line linear function that goes through the point P. Oh, no, that's looking at number 5 then. 3, -5, and the point will go on Q, 7, 4. Now, yeah, I can graph the points and try and be as accurate as possible, but that's not gonna be something that I can rely on. Now, in pre-calculus, if you remember these things very well, we had multiple versions, multiple forms for the straight line equation. You had the slope point form and the point form and the slope intercept form, which is, whoa, that was not what I wanted to do, which is this one. Whoops. This is going to happen all the time, so you're just going to have to remind me. This y equals mx plus b form, because I have the slope and the y-intercept, it's called the slope intercept form. Now, as much fun as it was in pre-calculus to have all these different forms, depending on the situation, the truth is we don't need them at all. The slope intercept form is more than sufficient to handle anything, even if I'm not given the slope and the intercept directly. I'm trying to find the values of the m and the b. So I know that the m is the slope m, and I just write it casually to remind myself it's the change in the y values of points on the line over the change in the x values. And I have 2 of them. So I can pick P and Q first and second and see how does it change from P to Q. Well, if I'm going from -5, let's do the x one first, because they're all positive. 3 to 7 is a change of 4, because 7 minus 3 is 4. So it's the end minus the beginning. So the change in the y values will be the end minus the beginning. And I get 9 over 4. You can write that 9 over 4 in any way you want, but I like to leave it as an improper fraction, because maybe in the future I have to interpret it or something like that. So then I update. Oops, what was that line doing now? Update. I have one of the numbers, 9 over 4 for m, and I still need to find the b. But that's okay. I know that both points P and Q sit on the line, and a point being on the line means that when I plug it into the equation, the left-hand side equals the right-hand side. So that means I can use either one of these and plug them in, and I still have an equation. Which one would you like to plug in? Doesn't matter. Q, avoid negative numbers. I hear that. Use point Q, for example. You could use the other one as well. So 4 for Y, 9 over 4 times 7 for X, plus B. Now the numbers aren't that nice, but it'll work. It doesn't always have to be nice, clean integers. So I simplify a little bit. 9 times 7, 63 over 4, plus B. You can also go, I don't really want to go decimal at this stage because I have my M as a fraction, but really whatever makes you happy. The point is we can easily find B. You can also use your calculator. It has the little fraction buttons, the ABC button, the scientific calculator that you're supposed to be getting. It looks a little like this. If you buy the newest one. There's a little ABC button above the 8. And even if you don't like fractions, you can use that. Type in 4 minus 63 ABC 4, that makes the fraction and leaves everything in fraction form. You can even switch between improper and proper fractions. However you want. You don't even have to switch to decimal. So if someone wants to calculate this as, I don't really like mixed numbers, so let's make it an improper fraction. What do we get? Good time if you just brought that calculator, maybe good idea to just look at it a little bit and be familiar with the options. Lots of options. You can be in any format you want, maybe fractions because I have my slope and fractionals already. You can do it by hand, of course. What is 4? 4 is 16 over 4. It's not even 64. I was hoping for something bigger. It's 16 over 4 minus 63 over 4. So 16 minus 63, you can just do that. To do something. What is 16 minus 63?
Negative 47.
Negative 47 over 4. You can leave it like that. You don't have to simplify it, but lots of options to represent that number. Know your options, and sometimes we are totally fine with decimals. Usually when it's a practical problem. I just like to be consistent that if I started with fractions, I'll just stay with that format and not mix and match. Maybe let's finish our equation. Y equals 9 over 4x minus 47 over 4, or whatever version you have for those numbers. So they're not always pretty. Fractions do happen sometimes. Doesn't change how we handle it. If you remember things very well, you can mix up the form. I have 2 points, so I can use the point form of the linear function. If you remember those things, honestly, you never really need it for a course like this. The slope-intercept form is more than sufficient.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.